Okay, great. Great. So thank you guys. What I thought we would talk about today is basically start to look at the question of like what does an ideal future for the Ethereum Layer 2 ecosystem look like, right? What are the things that if we build over the next few years, then we actually will have a layer 2 ecosystem that like really has all of the properties that I think people are looking for, and like where we actually get something that really feels like what we wanted once we were when we were starting this whole journey of thinking about how to scale Ethereum nearly 10 years ago, right? So Ethereum layer 2 is today, right? Ethereum has a lot of layer 2s, right? I still remember back in 2020 when there were still like maybe a couple of them, and then after that there were like five of them, and it's like, okay, we understand this. There's like there's Optimism, there's Arbitrum, there's Polygon, there's Starkware Land, and then there's ZK Sync, and like Ethereum's got its five layer 2s. That the whole thing makes sense. And then a year later, it's like, okay, wow, there's like a whole bunch of them, and now it's people are starting to say that there's like too many layer 2 teams at this point. I feel like the ecosystem has made a huge amount of progress. Also. Starting to, so I think the next thing that we want to make progress on is like not the quantity of layer 2s but the quality of them, right? And one of the most important metrics of quality is like basically like the security, right? This is a page from L2Beat, and the stages, right? Stage 0, stage 1, stage 2, basically tell you like to what extent is this roll up like actually something that's secure and trustless and like actually protected by the proof system versus stage 0, which is just a multisig, right? And like up until about a year ago, literally everything was just a multisig, right? Except for, I think, Fuel was stage 2 the whole time, but Fuel and Dgate, those are not EVM rollups, they're not general purpose rollups, right? They just are like serving a much more specific set of applications. And I think Fuel has a programming model to some degree, but it's like definitely not close to EVM, right? And as of about a month ago, Optimism has become a stage 1 rollup, so it's kind of halfway there from being just a multisig to being fully trustless. And so we now have two EVM rollups that are within that category, and both of them have plans to really start moving towards stage 2 over time, right? And DYDX and ZK Sync, and there's a lot of others that are following suit, right? So I'm looking forward to the day when Kakarot can also join the list. So hopefully that's going to come pretty soon. So a lot of I think the trajectory on quality of rollups is definitely going in a really good direction, right? So the big problems that I think we have today are, one is security and trustlessness, right? Basically, L2s like actually being L2s and not just being multisigs. 7-day withdrawal delay, this is just for the optimistic ones, right? If you're an optimistic rollup, you need to have some level of delay to ensure that if something wrong happens, then someone is able to push a fraud proof in to stop the wrong thing from being finalized. In the case of ZK rollups, the finality time is already much shorter, right? So in the case of Starkware, I believe batches are submitted like usually on the order of like about one every hour or so, right? So it's like already definitely getting there. But to me, the ideal is not even an hour, right? To me, the ideal is like for what is 12 seconds, right? Or even 4 seconds. So I'll talk about some of the tricks that we can do to try to actually get there. Cross L2 transfers are difficult, and like there's like a galaxy brain, like combinatorial shared sequencing way to interpret that problem. And like, I actually don't even believe that's the #1 priority. To me, this like isn't a math puzzle. This is a UX puzzle. And we'll talk about some of those things as well. Smart contract wallet support difficult, right? So we're like actually starting to really make headway on smart contract wallets, right? So 5 years ago, most people were just using EOAs. These days, like, like if we want to ask here right now, right, how many people here have a safe? See, lots of hands raised, right? So already a huge amount of progress. Who here has or is a member of a multi-sig wallet that's not a safe? Okay, see, so, so see lots of multi-sig adoption, right? And at the same time, we've been starting to see growth in both like sponsored transactions, like batched operations, a lot of other things, and we now have EIP 7702, which is going to get us this like very smooth path by which the kind of account abstraction for UX space and the account abstraction for security space can basically kind of proceed further along the same trajectory. And so we don't get these kind of two separate ecosystems. Then so a lot of progress, right? But the challenge is like on the cross layer 2 support is not great, right? Like there's layer 2s that have incompatible enshrined account abstraction standards. There's also just the fact that like if you have a multi-sig and that multi-sig exists on different L2s and you want to change the keys, you have to like separately change the key on every L2. So a lot of annoying things like that. Centralized sequencing is one of the other big bottlenecks in terms of security and trustlessness, right? So, like the point of the Ethereum ecosystem is not that like everyone just talks to servers, right? We want to be able to have like actually decentralized applications. And that's something that we've had on layer 1, but on layer 2, there's not enough rollups that are there. So like Tycho has a based, is a based rollup, and so I think it's good that that exists. And I would love to see more either based rollups or decentralized sequencing solutions or both. So the goal in one sentence, right? So I think that's kind of, if you zoom into the issues, right? If you kind of zoom out to, like what are we trying to accomplish? I think one of the ways that I think about it is that, using the greater Ethereum verse should not feel like you're using 40 different blockchains, right? It should feel like you're using Ethereum. So what we want is we want something that has the fees of Ethereum in 2015, and that feels like you're using Ethereum in 2015, but that has the scalability and the level of Ethereum in 2029, and that has the UX quality of Ethereum in 2029, right? And so basically the question is like, how do we actually get there? So I think from a UX side, I kind of just wants to actually skip ahead a bit and like change the order around, right? So this is something I tweeted out a couple of days ago, right? So the experience depositing to Polymarket today, right? Basically, so Polymarket is, as the name implies, on Polygon, and so if you deposit to Polymarket, you get to this page where like there's an address, and like if you want to deposit coins to it, then like you have to select Polygon as the network and not Polygon ZK EVM, and then you have to make sure and you like deposit your funds, and if you do it wrong, then like your money gets stuck, right? It's like imagine you're asking someone to like pay you your salary, and you have to tell them like, no, my bank is JP Morgan. It's not Morgan and Chase, it's JP Morgan. Those are actually totally different. And like, if you get it wrong, then like $100,000 disappears, right? So this is like where we are now, right? And like, this is something that we really, like have to move beyond. And so the thing, and then even if you get past that whole problem, there's the problem that like currently, bridging is like considered this completely different operation from sending, and you have to like bridge through bridging protocols, and like how does this even work, right? And so what things should look like, right, is so there's ERC 3770, which makes which basically puts the name of the chain into the address. And so here basically it will just have one page that just says deposit USDC to this address, and the address just is, like whatever the name of the chain is, colon, and, and then whatever the address inside the chain is. And then you'd be able to copy that, and then you would be able to just like put that straight into the to field of your browser wallet, and then you'd put that straight in there, and then it would click send. And if you already have coins on the same layer 2, it would just send those coins. If you don't have coins on the layer 2, it would just automatically send them through some kind of cross layer 2 bridging protocol, right? So if we do this, then sending feels like sending, regardless of whether you're sending within one layer 2 or whether you're sending across layer 2s. And the whole experience basically feels the same way that everyone being on Ethereum together in like 2015 to 2019 felt, except you just have like, the name of a network in front of an address, and like people can kind of, if they don't want to think about it, they don't even have to think about it, right? So I think we can like actually get to this, right? But this is, like why I'm basically saying like this is, this is like 10%, like fancy math and figuring out synchronous combinatorial stuff, and like 90% is just like very basic UX issues. So I think we can actually get to this, right? So I think, the question now is like basically, like what are all of the other different pieces that really need to fit together to make the layer 2 ecosystem really be what we want it to be. So let's talk about getting to stage 2, right? So today we have rollups that are stage 1, and stage 1 basically means you have some kind of proof system. The proof system can be optimistic, can be ZK, whichever one, and then you can have a security council, and that security council is like basically a multisig, and the multisig can go in and it can overturn the result with a 75% threshold, right? So you need basically, if the proof system is doing right, like if everything is fine in the proof system, then you would need a 75% threshold of this group in order to take the money out, like maliciously. And then if the proof system is wrong, then basically, as long as 75% are still honest, then like they would be able to like basically go in and fix the bug, right? And like that difference between 50 and 75% is like actually pretty huge, right? Like there actually have been some multi-sig hacks. Like there was one hack where there was this like I think it was one of these like centralized like multi-sig bridges, and I think it was like a 5 out of 9, and like literally 5 of the keys out of 9 got hacked at the same time, basically just because like a bunch of them were on the same computer, right? And like if that had been up to 3/4 threshold, then like it seems very likely that the hack could not have happened, right? So I think, so what stage 2 says is it basically goes further, right? Stage 2 is like the first one, it's like the stage where you can actually say that it's trustless. And the reason basically is that as long as the way that the stage 2 rules are designed is that as long as there are no bugs in the code, the Security Council has no power, right? So the way that stage 2 works is that the Security Council only has power if the code provably disagrees with itself, right? And so how can the code provably disagree with itself? Like one example would be that if someone submits basically like 2 different state roots and both of them with the same data and both of them pass the proof system, right? Another one is like if no one submits a proof for a week, right? So like a liveness failure instead of a safety failure. A third one is if you have 2 different proof systems and those proof systems disagree with each other, right? And so, here, for example, like in this diagram, you could imagine like a 2 out of 3 between a ZK proof system, an optimistic proof system, and like in this case, a 4 of 7 Security Council. And the Security Council would only have the power to basically choose which one of the 2 is correct, right? So even if there is a bug, like if the ZK thing says A and the optimistic says B, like the Security Council can't just like go and say, aha, we have a bug, and so now we're going to say it's C and we're going to take the money for ourselves, right? It's like, no, the Security Council can only choose between A and B, right? So multi-provers are one of the options, and like this is something I've been talking about for a long time, and like I know Optimism is getting into multi-provers, Tycho is getting into multi-provers, so a lot of good work happening on that. Another one is formal verification. There's an increasing amount of work starting in figuring out how to formally verify an entire like ZK EVM verification pipeline. And within Starkware and Kakarot land, I know there has been a formalization of Cairo, and Cairo has been kind of like that's been fully like end-to-end proven, as I understand, like even including the the arithmetization, and basically the goal is to try to like extend this to ZK EVMs, right? And it's starting to feel like the most viable route to doing this basically is to just kind of like piggyback off of an arithmetizations of something simple, so either RISC-V or Cairo, and then you basically like formally verify the EVM in that, and then you have you formally verify a prover of like Cairo or RISC-V, and then you basically have it, right? And then if we have that, then like you get this like very strong assurance like in the actual technology itself, right? And at some point, like there becomes much less pointed having 5 different proving systems if you can just prove that those 5 different proving systems like actually are proving things that are all isomorphic to each other, right? So that's one big part. And so now let's talk about how do we get from 7-day withdrawal times to 4-second withdrawal times, right? So 7-day going down to 1 hour is easy, right? You just like switch from optimistic to ZK. Going down from 1 hour to 1 slot, that's the challenging thing, right? And so there's 2 challenges that both have to be solved. The first challenge is that ZK EVM proofs today, they take a long time. They've been improving a lot, right? Like I still remember like 1 or 2 years ago when an average case proof of an Ethereum block would take 5 hours. And then today, it's, you have like average case proofs of an Ethereum block that are like 20 minutes, and then the worst case is like only a few times more than that, right? And there are things that we can do, like either like, on an L1, but then in this case, you only have to do it on an L2, like kick out catch-check and replace it with a better hash function, increase the gas costs of some precompiles, do a couple of other things, right? And you could get rid of the worst case, but then, the average case still takes like 20 minutes, right? And the basic reason why is that ZK proving currently is not parallelizable enough, right? Basically, you have one machine, that one machine is doing all of the proving, and so ZK proving like inevitably has an overhead of like, a factor of 100 to 1,000 compared to regular computation, and the problem is that if that overhead is all happening on one machine, then like that turns into a factor increase in time, right? Like 1 second turns into 1,000 seconds. So in order to get past this, like the easiest way to do this that we know how to do already is to parallelize, right? Basically, what you do is, so first, you have an EVM block verification computation. Then you have an arithmetization, which could be some kind of direct arithmetization, or you could like basically stick an EVM runner into Cairo or RISC-V, and then you just basically have like a very compact virtual machine that just executes for like 10 million steps. And then inside of that virtual machine, what you then do is you split the proving into pieces, right? You basically take your 10 million Cairo steps, and then you split them up into 1,000 pieces, and then you have 1,000 pieces, each of which have 10,000 Cairo steps, right? And then for each one of those, you just separately make a proof. And then each one of those is only like 1,000th of the process of verifying an entire Ethereum block, and so you can make a proof for each one of those pieces in a second, and then you make up for that by just like having lots of machines, and then this is like in theory not too hard to do if you know how to do like DevOps magic in like AWS or whatever, right? Or you just like get 1,000 GPUs yourself, or like you just like, I don't know, like hope that the AI bubble is going to pop soon or something. But like if that doesn't happen, then there's still, actually, if it doesn't pop, there's like that just means there's going to be even more compute, right? And so you just like if you can parallelize, you're fine, right? And then once you have your proofs, then basically you have an aggregation tree. You take like 2 of the proofs, turn them into like make 1 proof of those 2 proofs, or realistically you could even go like 4 to 1 or like 8 to 1 or whatever, right? And then you make a proof of the proofs, make a proof of the proofs, make a proof of the proofs, and you have 1 proof, right? And like theoretically, there's like basically none of this relies on any kind of fundamental discoveries that we don't have, right? Like this is something that if you can parallelize enough, you can like do something with present day technology that can prove Ethereum blocks in real time, right? In less than one slot, right? Like recursive proofs, there's been numbers that you can do that in, I think like 170 milliseconds in Plonky 3. So it's basically the challenge is like not fundamental. The challenge is like these kind of technical things, right? Basically, one of the biggest issues is basically if you're going to like have this proof over a lot of Cairo steps, then like how do you actually like stitch all of the different proofs together, right? And there's like easy ways to do it, which is just like you put the entire state of the VM into a Merkle tree, and there's possibly more complex ways as well. But like this is one of the things that we still need to like think through how to optimize, right? But like this is the end goal, right? And if we get to this end goal, then one of the big hurdles in basically is having ZK rollups that commit every slot is going to be solved. The other hurdle is we need on-chain proof aggregation, right? So the big reason why something like Starknet doesn't commit more frequently is because a proof has a high overhead. It's like something like 1 to 5 million gas, and like you don't want to be paying 1 to 5 million gas every slot. And like realistically, if you imagine like both Starkware Land and Optimism and Arbitrum and Polygon and like 3 other ecosystems all committing every slot, then that's already enough to just like fully fill the an Ethereum block, right? And so the way that I think we need to solve this problem is basically with on-chain, with proof aggregation mechanisms, right? So basically, you imagine you have like a bunch of different rollup ecosystems that all submit a proof, and then off-chain, you just basically have a mempool. The proofs go into the mempool, and then you have one actor that gathers the proofs and then turns the proofs into a single aggregate proof of the proofs, and then just like puts that aggregate proof of the proofs into a block, right? So this is something where like it's basically just an engineering task to like actually build something like this. But if you do, then the economics of every individual rollup publishing much more frequently are going to start to actually become much more viable, right? And then what kind of proof scheme does it make sense to use for this kind of like ultimate prover of all proofs? I think realistically, you want something that has maximum security and minimal assumptions. And what does that mean? That basically means like Starks with the parameters like set so that you have like unconditionally provable 128-bit security, right? So that's like this is also something that I think can really help push the L2 ecosystem forward. So talked about cross L2 transfers. Key store rollups, another one of those interesting topics, right? Basically, like you can have an account where that account and like the logic of that account lives in one place, but then you can spend from anywhere, right? And so you could have a safe. The logic of the safe lives from one place. You can update your safe in one place, and then you can spend on any L2, and when you spend on any L2, you're basically like real time creating a proof of the of your state on like wherever your account lives, right? And there's like an easy way and a hard way to do this. The easy way to do this is your account still lives on layer 1. And now that layer 1 is cheap, like this is starting to become more doable, right? And like if we, and so there's like basically if you want to do this, then the main property that the layer 2 needs to have is it needs to be able to directly read layer 1, right? So this is something that Optimism has. This is something that Scroll is doing, and this is something where I think there's starting to be work in trying to standardize one or a couple of versions of this into an RIP. And so this would be amazing if you have. And then the more complex version is you basically put the state of your account into one L2, and then you just use like cross L2 branch proving to prove it into anywhere else, right? So sequencing. Status quo, basically rollups are doing sequencing themselves. And I think there's like 2 possible futures here, right? And they're kind of the more L1 minimalist version and the more L1 maximalist version. The more L1 minimalist version basically says, rollups just end up doing decentralized sequencing themselves. And like that could be some kind of shared sequencing. It could be every L2 doing it on its own or something. And then the other future is that L1 gets somewhat faster confirmations, and then you just get more based rollups, right? And so if a rollup is just based, so it just basically does sequencing by just accepting submissions from anyone, then like that's just like a much more decentralized architecture that you get for free, right? So like these are like some of the big technical directions that I find valuable, right? But then like what do we get as a result of implementing all of these things, right? And to me, like I come back to like the vision in one sentence, right? The vision in one sentence is basically you want something that has the fees of Ethereum in 2015, which means that like you're basically free, like regular transactions for under a cent. You want something that feels like Ethereum in 2015, right? Which basically means that like it just feels like you're sending coins between addresses and like you're doing calls between addresses. But where at the same time you have the scalability and the UX of the year 2029, right? So you have something that is ultra cheap, but is serving a really huge number of users, and where under the hood, it's this complicated, like asynchronous layer 2 centric ecosystem where you have like a whole bunch of these different layer 2 universes that have various different properties. But from a user's point of view, it just looks like you're sending things from Ethereum addresses to other Ethereum addresses. So 100K plus TPS across the Ethereum ecosystem. I actually think we're going to be able to get even higher than that, especially if you include like plasmas and off-chain DA things in that list. Fast performance applications with a high level of decentralization, trustlessness, and censorship resistance. Which L2 you're on is much less visible to a user, but I think it also should not be completely invisible. Like I think the differences between security models matter, right? And users should see, like are they interacting with something on a secure ecosystem, or are they interacting with something on a less secure ecosystem? Basically, you get the kind of advantages that we had, like in Ethereum as a small ecosystem, and the advantages of this like highly developed and highly performant big ecosystem at the same time, right? So I think that's the ultimate goal. And then on top of that, obviously, like ultra fast transactions, right? So basically, from a user point of view, like you should be able to get like for applications that need it, you should be able to get a confirmation within a couple of seconds or even within 1 second, right? And, obviously 2015 Ethereum, like if you send a transaction, often it would take like 5 minutes to confirm. So I think if we get to all of these things, then like we get to an Ethereum ecosystem that like really has really amazing UX, right? And like any like fragmentation problems end up, like not being visible to users. And to a user, it just looks like you're working with Ethereum. And at the same time, we actually have amazing scalability, and we have all of this amazing layer 2 like roll-up enabled innovation continuing to happen under the hood. And at the same time, we actually get to kind of this some kind of singularity where where from a security perspective, like the level of robustness like actually starts increasing, and we actually get to the point where we're like more confident in the security of every layer of the stack than we were at any point in our history. So I hope that we can all work together to get there. Thank you. Thank you.
Thank you. Sorry. We have time for a few questions. Okay.
I'm Lim from Talos, and we're also currently working on a protocol that is decentralized recursive proof aggregation. I think all these look wonderful. The question to ask is that when are we going to get this?
When someone builds it, I think is the answer. Again, I think like technologically, we're not far away from any of this stuff, right? Like, like we can literally do like 600,000, like Poseidon hashes per second on an M3 laptop now, right? So I think it's like this is the big difference between now and 3 years ago, which is that like now there aren't any fundamental research questions that are stopping this from being possible. Now it's just like implementation, standardization, and like having the thing in some kind of form factor that makes it actually usable for people.
So which means we've overcome the research and development stage, and then what will be the timeline like?
That's that's not my job. That's your guys' job.
Okay. Then second question. Second question is not relevant to Ziki. I just want to dive into your brain and understand. In the last crypto cycle, NFT was the one increased, and then for this cycle, what do you foresee would be then coming?
I mean, I think the applications that we've seen like become the most uniquely successful this time. I mean, one is the whole decentralized social space. Two would be Polymarket. Three would be just continued just like people using crypto for payments in like especially just like person-to-person international payments in all kinds of contexts. Yeah, I mean, I feel like those are like, I mean, three of the bigger ones, and then there's like a long tail of various other things that are continuing to grow as well.
Thanks. Okay, so we have 4 questions. Please keep the questions like one sentence.
Thanks, Vitalik, for your speech, and it was quite abstract. Oops, sorry. Quite abstract, touching the whole Ethereum ecosystem. But could you tell us a bit more about your connection with Kakarot and why did you choose this?
Yeah, I mean, I've been, first of all, just been a big fan of the Starkware ecosystems, like work on Starks and taking this, like really rigorous job of just like valuing and pushing forward on the technology. And Kakarot's been a really crucial part of that, like by building a ZK EVM on top of the technology. And so I see it as, like being definitely, like one of the most advanced efforts at building a ZK EVM, which is valuable both for the layer 2, any kind of EVM layer 2, and eventually for layer 1 as well. So I think all of these things are like that entire stack, including the Kakarot code itself, including Cairo, and including Stark technology, is just it's great tech, and I think there's a lot of value in that continuing to improve.
Hey, thanks for your talk. Quick question: you mentioned reading the L1 from the L2. What do you think of the approach to have the root hash available on L2? With a cheap proof, wouldn't that solve the issue?
Yeah, so I think there's like some strengths and weaknesses of that route, right? So if you just have the root hash, I mean, the strength is that it's just much easier to implement, right? Because L2s need to have access to L1 hashes anyway, because you need to have infrastructure to accept deposits, right? And so you basically just like piggyback off of the exact same infrastructure and you just make the hash accessible. The weakness is that you don't get like synchronous reading ability, right? So like if you zoom into the key store rollup use case, what basically what you have is, right, like you have like let's say you have a safe on an L2, and then in like normally when you have a safe, the safe when you get a transaction, it verifies the signature and then it does an operation, right? To verify a signature, you have to verify it against a public key. And like normally today, the public key just like lives in the same place, right? If you do reading, then like you just take the public key and you put the public key on L1 instead, right? And so if you have like actual like state reading, like either L1 S load or like L1 EVM call, if you have either of those, right, then like you're basically able to replicate that exact same workflow. well, whereas if you only have state root access, then the challenge is like basically you're going to have like that transaction is going to have to like include some kind of ZK snark of a proof, and like you basically have to like build a whole bunch of layer 2 infrastructure. You have to worry about the possibility that like you send a transaction and then the root changed and the proof is outdated. So like, you know, you basically, you get your like, you know, like base level simplicity, but you end up paying for that in like a lot of account level complexity. Yeah.
Hello, Vitalik. So I had my question was, in the upcoming future, do you see we would have few rollups like high capacity rollups bringing the whole 100K TPS vision, or do you think that the future will be where every application has its own rollup and then we discover abstractions to make them talk?
I feel like so far it's been like mostly the second, right? Though, I mean, I expect what we're going to see is yeah, like especially out of the larger applications, like some of them will have their own layer 2, some of them will be like on one of the general purpose layer 2s, and then smaller applications, they'll just be on some kind of larger L2. And then, you know, we'll see some kind of split between rollups and validiums, right? Where I think rollups make more sense for like higher value financial stuff, and validiums make sense for like anything that just doesn't require quite that security level and is okay with lower fees, right? So like anything like games, for example, or like a lot of social stuff should be either a validium or even some other structure. So I expect we're going to continue to see a mix.
Hey Vitalik, thanks for the talk. A lot of your slides were kind of EVM rollups, and part of the rollup-centric roadmap was to explore different execution environments. How do you think we keep the same UX and standardization across different execution environments? What do we need to do?
Yeah, I think we need to have kind of like a concentric circle of like different tiers of standards, right? Basically, where even if you're not being like exactly EVM equivalent, there's like different like common layers that you can still agree on, and you can still get like a lot of the same benefits, right? So like if you think of like ERC 3770, for example, right? Like if the ecosystem standardized around that, then like that has no dependencies on like any specific VM architecture, or like even signature scheme or anything whatsoever, right? So that's that's one example of a standard that like actually would make life easier for non-EVM rollups, because it helps us move away from the world where we assume that you have the same address on every chain. Because like having the same address on every chain is like a big like killer for any kind of L2 that wants to experiment with VMs, right? Then another piece of this is for key store rollups. Then like if you take the design where like you actually like have the like public key stored in one place and then you can like read, then like that becomes very friendly to having a lot of different VMs, right? Because if you take the current approach, which is like you have a copy of a safe everywhere, then like you can't have a copy on things that are non-EVM. Then yeah, like I think like moving away from the norm that like having the same address on different chains is like something we strive for. I think for smart contract wallets, like that's just like basically mandatory. Then in terms of other standards, like standards for moving assets between chains, so like something like 7683, like I think you can like I feel like even in its current form, it's like pretty close to something that's that non-EVM chains can interoperate with. So I think we just have to like look at it standard by standard. But I think there's still a lot of things that even non-EVM chains can agree on.
Cool. Thanks, everyone. So we're going to take a small break and move to the next panel, which is a discussion about the Cambrian explosion of rollups and how to navigate this trade-off and design space.